So I should mention there was an error in the solution I went over with you last time, and about 10 of you got the right answer, and none of you said, "Hey, you're wrong." So I was like, "Why everybody keep getting the same answer, and it's different than my answer?" You know. So the problem was on problem 4, and the answer that I showed you guys last time. What was wrong with the way I did it? I mean, what I did was correct in and of itself, but the trouble is, when I copied this problem down wrong, I didn't keep the x there. So when I did this problem, I didn't transcribe the x, which means I had 4x squared minus 4, which then simplified to x plus 1 times x minus 1. Whereas the correct thing here, there's an x that factors out, and then x times x minus 4. So it's similar, but my solution that I showed you last time is wrong because it's not the problem which is given. All right, so I still need to correct the solution that's posted for quiz 3 to address this. I haven't done that yet, but I should. All right, I just wanted to make sure I told you that, and just in case I forget or something, technically speaking, the solution I showed you to problem 4 last time is slightly off because I solved a different problem than the one that was stated. And so I was very happy to see, like about 10 of you got it right. Right, so, all right, with that, out of the way, are there any questions about the My Math Lab? Since I got this out, I can look at some problems. If you're stuck on something in My Math Lab, now would be a good time to ask me about it. If not, I'm going to put this away and work problems. All right, I take that as a not. Let me close this down here. Oh. I'm afraid if I leave that on and the light's off, we're all just going to go to sleep, If you're wondering, apparently there was a skunk on the other door there or something, and it must have sprayed, and then... So I think it seems like they've gotten a lot of the smell out. I noticed they have an air purifier going in the hallway, so... I walked in here this morning, I was like, no. That's not right. So, I don't think it's as bad now. All right, so let's look at some more problems involving radicals. Probably you guys would benefit from seeing a few more examples of these. So I'll work, let's see here. The square root of 2x minus 5 all right, equals 1 plus the square root of x minus 3. So you guys tell me, what should I do here? Should I solve this? What have I told you guys? We need to isolate the radical, right? But in this problem, like isolating the radical, hey, it's already done, right? Like this already has the radical isolated, right? Like it's all, here's the radical. It's already by itself, right? So what do? In this case, we can just square both sides, right? So here we go, square both sides. So on the left-hand side, we just get 2x minus 5. On the right-hand side, I'll write it out. So when we multiply this out, how does that go? That goes, you've got 1 plus the square root of x minus 3 plus the square root of x minus 3 plus the square root of x minus 3 quantity squared, right? So that simplifies a bit because we can collect like terms, and the square root of the squared thing is just the thing again. So we've got like 1 plus twice the square root of x minus 3 plus x minus 3. So once we get to this stage, now we only have one radical, right? And so our next goal is isolate. We want to isolate the square root of x minus 3, essentially, right? So we were going to subtract and move things to the other side as appropriate, right? Let's see here. So let me write it out. We've got 2x minus 5 minus 1 minus x plus 3 equals 2 times the square root of x minus 3, right? So I just subtracted 1, subtracted x, added 3 to move everything to the left-hand side. And what do we have? Well, looks like we've got x minus 6 plus 3 is minus x. So we've got x minus 3 is equal to 2 times the square root of x minus 3. Now, we could divide the equation by 2 if we wanted to, right? Or you can square it if you want to. I mean, it's up to you. What do you guys want to do? Choose your own adventure. Divide, then square, or just square? Just square. I think just square is good because then we don't have fractions. So I will square it. We have a square to spare. Let's see here. So squaring x minus 3 gives us x squared minus 6x plus 9, all right? And squaring the other side gives me 4 times x minus 3. I can write out more steps if you want, but what's that? Oh, well, that's a quadratic equation, isn't it? But it's not in standard form yet. We need to move everything to the one side or the other, right? So I'll FOIL this out here. We got distribute rather 4x minus 12, right? So what do we have here? We've got x squared minus 10x. Add 12 to both sides gives me plus 21. Right? Now, this is a quadratic equation, which means we can solve it, right? Either by factoring, completing the square, or using the quadratic formula. Factoring is always fastest if we can do it. Can we factor it? What's that? 7 and 3. Minuses or pluses? Both minus, right? X minus 3, x minus 7. Very good. And so our potential solutions are what? X equals to 3 or x equals to 7. Those are potential solutions. I say potential because, remember, we squared the equation, which means that those may or may not be legit solutions to the original problem, right? So what I need to do now is to plug those back into the original problem and see if they work, right? So I'm going to check my answer. I'll do it up here, check answer. So let's see here. For x equals to 3, the square root of 2x minus 5 is equal to what? The square root of 6 minus 5 equals to 1. And 1 plus the square root of x minus 3 is equal to 1 plus the square root of 3 minus 3, right, which is equal to 1. So comparing these two, we have shown that they solve the equation, right, because the left-hand side matches the right-hand side of the original equation when we plug in x equals to 3. That's good. Now we need to check the other answer. Let's see here. X equals to 7. Square root of 2x minus 5 is the square root of 14 minus 5, also known as the square root of 9, which is 3. But on the other hand, we have 1 plus the square root of x minus 3 is 1 plus the square root of 7 minus 3. which is what? 1 plus the square root of 4, which is 1 plus 2, which is 3. So these match up, and that also works. So in this particular problem, looks like we didn't get one answer is right. We got both of them, right? Both of my potential solutions were actual solutions. There was no extraneous one in this case, right? We've seen a lot of problems that had one true solution and one extraneous problem. I worked one example where there were no solutions at all, right? So there's a lot of different things that can happen with these radical equations, is my point. Any questions? All right, well. Let's work another one here. Let's solve the cube root of 3y plus 6 the cube root of 3y plus 6 equals, well, excuse me, that plus 2 rather, plus 2 equals to 3. All right? So the first order of business is what? Isolate the radical, right? So how do we isolate the radical here? We just have to, what? Subtract 2 from both sides, right? So this gives us the cube root of 3y plus 6 equals to 3 minus 2, which is 1. Now what? So word of caution, I saw on some people's quizzes that we had a problem in the quiz with a cube root, and rather than cubing it, like you thought of it as a square root, you just squared the equation, right? But when we have a cube root, to undo the cube root, we have to cube. That is, raise both sides of the equation to the third power. And so beware of that, because some of you are only thinking square roots, and that's just part of the story, right? We also have cube roots. So just a cautionary tale there. Aaron, right? Yeah. So let's cube both sides. Here we go. Cube, and then others of you on the quiz, you were careless with your cube. Like 3 cubed, a lot of people said was 9, right? But 3 cubed is not 9. It's 3 times 3 times 3, which is 9 times 3, which is 27, right? So I saw about, I don't know, maybe 7 people make that mistake, something like that. I'm not sure if any of those people are here at the moment, but who knows? Maybe they'll watch the video. All right, so 3y plus 6 equals to 1 then. So then we need to solve for y. So subtract 6 from both sides. What do we get? 3y, 1 minus 6, which is minus 5, right? So 3y is equal to minus 5. Now solve for y. What do we get? Yeah, negative 5 over 3. You got it. And there it is. That's the answer to this one. Let's see here. Let us look at this problem. So here we have the 4th root of y minus 3 equals to 2. Instead of using y, I'm going to use x. X is more fun. X, the 4th root of x, what did I say, minus, where'd it go? I'm trying to pick problems out of your book, you know. Yeah, the 4th root of x plus 3 equals to 3. That wasn't the one I said, but it's about the same. So we'll do this one. So in this case, the radical is already isolated, right? So how do we get rid of a fourth root? We do what? Raise it to the fourth power, right? Exponentiate both sides to the fourth power. Raise both sides to the fourth power. And what is 3 to the fourth power? I mean, I can write it out. It's 3 times 3 times 3 times 3, right? I heard an 81. That is correct. Because 3 to the fourth is 9 times 9, 81. And of course, we have x plus 3 is equal to 81. So what's x equal to? Yeah, 78. Very good. Look at another one here. X minus 1 equals to the square root of 1 minus x. All right, so how are we going to solve this? Well, it looks like the radical's already isolated again, right? So all we got to do is get rid of the radical by, in this case, squaring both sides, right? So x minus 1 squared is equal to the square root of 1 minus x squared. And what do we get? When we square x minus 1, we get what? X squared minus 2x plus 1. And that's equal to what? That's equal to 1 minus x. Now, let me, just in case you don't understand that step I just made, first of all, if you don't understand, you should just, like, stop me and say, I don't understand that step. And if you're here right now, then you can do that, right? But in case you're not and you have that question, here's the details. X minus 1 squared, remember, is x minus 1 times x minus 1, right? And so when we multiply that out, we get x squared minus x plus 1. Look, foiling that out, if you will, distributing. And so we can collect the like terms. And what we have is x squared minus 2x plus 1, which of course is what I wrote over here. So that's the internal logic of that step. But honestly, I don't think through that when I do that multiplication. I just kind of have a shortcut there in my mind if I'm squaring a binomial. I know I do the square of the first term plus twice. I mean, here's the pattern I use. I go back to this pattern, guys. If I have a plus b and I'm squaring it, I just write down a squared plus 2ab plus b squared. So this is a shortcut formula that I use. That's hardwired into my brain. Technically speaking, you can work that out by doing these multiplication steps, right? But obviously, this is like way, way faster if you're just in the midst of things. So I would recommend that you memorize that shortcut and put it into practice. That's what's best for you in algebra. Okay, anyway. So you got x squared minus x. So we got, let's see here, we got 2x squared minus 2x equal to 0, right? The ones cancel. And then you said we can divide by 2, right? We can divide by 2 if we want. Just divide by 2. There's 2 above. And this is x times x minus 1. Is that what you told me? Or you just said x squared equals to x? I mean, x squared equals to x is the same as that. But this has the advantage of, it's factored, right? So we can use the usual theorem and say, okay, well, the solutions are what? Potentially x equals to 0 or x equals to 1, right? I say potentially because we squared the equation, which means we have may have added solutions which aren't actually solutions, right? Extraneous solutions. So are those both legit solutions to this problem? What do you think? Start with 0. Is 0 a solution to this problem? Right, if we plug in 0, we get minus 1 equal to the square root of 1, right? False. So that doesn't work, because minus 1 is not equal to 1, right? But on the other side, put in 1, plug in 1, you get 1 minus 1, which is 0. You get the square root of 1 minus 1, which is 0. 0 equals 0. Hooray! So 1 is the solution to this problem. Right. All right, so I think what I'm going to do now is I'm going to go back earlier in the chapter, and I'm going to do a bunch more examples of exponents, because I think you guys need more practice on that. All right, so basically I'm going back to section 6.2, and I'm going to work a ridiculous number of problems in that section with the hope that it rubs off on you. So we'll start out with the instructions. Rewrite without rational exponents and simplify if possible. So that's the instructions we're dealing with for the next batch of examples, okay? And I think what that means will become clear as I start working examples. So like example 1, y to the 1/7. Excuse me, example 5. Y to the 1/7. How do I write that without using a rational? See, that's a rational exponent, because it's a fraction, which is the exponent. So to rewrite this without using that notation, I got to do what? The seventh root of y. So this is exponential notation. This is on the other side, we're using the radical notation, right? All right, so it's kind of a silly problem, but if anything, it's teaching us the words, right? Another one, x to the 1/6. Yeah, 6th root of x, right? Example, let's see here, next one. X squared, y squared. X squared, y squared, all to the 1/3 power. Yeah, so this gives us what? X squared to the 1/3, right? Y squared to the 1/3, and how does that simplify? Oh, I guess that kind of tells me what to do, doesn't it? So I want to get rid of the exponent, the fractional exponents, right? So in this case, I would do the cube root of x squared, right? And the cube root of y squared. Now, of course, what's another totally, this is like one way to write the answer. There are at least two legitimate answers here that you could give. I don't know, the question is what you mean by simplify, right? So certainly another answer that could be given here is that this is just straight up equal to the cube root of x squared, y squared, right? That's what you're thinking. And then, of course, yet another answer that could be given here. So beauty is in the eye of the beholder. What's more simple? That's also xy squared. So in my book, any of these three answers are legitimate answers to the question, because they've all made a simplification of one sort or another, and there's no fractional exponents in the answer. I try hard not to ask questions that have this kind of ambiguity on the test, you know. So when I ask the exponent question, I like to ask it like I asked it on the quiz in problem 2. See, there's no ambiguity in that problem. You find A and B, right? Here, let me redo this one as example 8 in the format of my quiz, all right? So like x squared, y squared to the 1/3 power. Write that as, you know, x to the a over y to the b. Find a and b. So I'm pausing my instructions for a second, okay? Instruction pause. All right. So what we do in a problem like this is we kind of have to manipulate the expression until it has that form, right? So what we have is we have x squared, you know, x squared to the 1/3, right? Y squared to the 1/3, which of course is x to the 2/3, y to the 2/3, right? So x is already where it needs to be. But if I bring y downstairs, what's the exponent on y? If I move the y from the numerator to the denominator, what do I have to do to y to the 2/3? Y to the 2/3 is equal to 1 over y to the what? Fill in the blank here. Similar but different example. I can rewrite x squared as 1 over x to the minus 2. Same idea here, but what do we get? If we move the y down here, we put y to the minus 2/3. All right, so when we move a factor with a particular power from the numerator to the denominator, we have to flip the sign on the power. And vice versa, the same. If we move it from downstairs to upstairs, we flip the sign. Yeah, so I mean, this is the right format, right? So yeah, it's minus y to the minus 2/3 when we move it downstairs. And so that means for my problem, a is equal to 2/3, right? B is equal to minus 2/3. Let's see here. Let's do more of these. I'm going to unpause the instructions again, okay? Example 9. Unpause. Example 9. 49 to the 3/2 power. How do we write this without a fractional exponent? So this is, we could look at this as 49 to the 1/2 power cubed, right? I mean, I think that's the smart way to do this, because what is 49 to the 1/2 power? Well, that's the square root of 49, right? Now, of course, in one sense, I've already satisfied the instructions, right? I've removed the fractional exponents. But this one we can simplify. What's the square root of 49? So the square root of 49 is 7, right? So this is actually 7 cubed, which is 7 times 49. Seven times 49 is what? 350 less 7, 343? Yeah. So there you go. That's about as simple as you can get. How about the next one? 4 to the 7/2 power. Let's simplify that. So again, pretty much the same strategy as the last one. Bring the half, look at 4 to the 1/2 to the 7th power, which is the square root of 4 to the 7th power, which is 2 to the 7th power, right? That's 128. I think. Well, 2 to the 3rd is 8, right? So one way you could break that down is 2 to the 7th is like 2 to the 3rd times 2 to the 3rd times 2, right? Which is 8 times 8 times 2, which is 64 times 2, which is 128. I mean, however, you can pick up your calculator, whatever floats your boat, but 2 to the 7th is something we can calculate, right? Without too much work. Okay, so the next bunch of examples, we're changing the instructions again, all right? Rewrite with rational exponents. So we're going to start with probably radicals and try to eliminate them and rewrite it in terms of exponents, all right? So here we go. Example 11. Here we're looking at the 7th root of x cubed y squared z squared. And example 12, I'll write out here while I'm at it. The 7th root of 8x squared y parentheses to the 5th power. And one more example of this type, 13, I'll do the where to go? The cube root, the square root. This one will be kind of anticlimactic after the other two, but the square root of x cubed. There we go. So again, our goal here is to remove the radicals and to rewrite with exponential notation. So what is this first one? It is x cubed, y squared, z squared, all to the what? The 1/7 power, right? Now, I think that actually is an answer that satisfies the instructions. But what's another algebra step we could make here if we wanted to? Right, yeah, so this is what? This is x squared, yeah, 1/7, right? Y squared to the 1/7, z squared to the 1/7, which of course we can likewise equivalently write as x to the 3/7, y to the 2/7, and z to the 2/7, which I think is what you told me a second ago, right? You could do that. So what's in red is a legitimate answer. What's in blue is a legitimate answer. Either way, we're not writing the answer with radicals, right? How about example 12? We have 8x squared y, all to the what? To the 1/7 power, big parentheses, to the 5th power. So by laws of exponents, that's the same as parentheses 8x squared y to the 5/7. So there you go. You could leave the answer like that, given the instructions here. Okay. How about example 13? How do we get rid of the radical? What does the radical mean in terms of exponents? This is a square root, so that's x cubed to the 1/2, right? Which I think is nicer to write as x to the 3/2 power. Any questions? All right, so the next instructions, we're going to rewrite with positive exponents. All right, rewrite the expression using positive exponents. So we want only positive exponents in our final answer. So there could be division, all right? See how this goes. So we'll start out with something, and we'll simplify if possible, right? So again, we're still in section 6.2. So here we have 27 to the minus 1/3 power. So how can I rewrite that just using positive exponents? What does that mean? That's 1 over 27, right? To the 1/3 power. What is 27? 27 is 3 cubed, right? So we're actually having 3 cubed to the 1/3 power, which is just 1 over 3 to the 1 power, which of course is just 1 over 3. So that's about as simple as you can get, right? Another way you could look at this is that 27 to the 1/3 power is the cube root of 27, right? Which maybe you might more easily recognize as being 3, if you know your basic cube roots, right? I don't know the cube root of too many numbers. I can tell you, like, cube root of 8 is 2, cube root of 1 is 1. The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. That's where I stop. I forget what's 6 cubed. 6 cubed is what? What's 6 times 6? 6 times 6 is 36, right? 36 times 6 is 180 plus, I can't do it in my head. It might be 216, I can't remember. I really should have my calculator for these kind of discussions. Anyway, my point is I don't remember the cube root. I don't remember what's 6 cubed personally, but 216? So the cube root of 216 is 6, all right? But that's not something I would know off the top of my head. Was that a lie? No? Oh. It's okay. So I have to keep on top of the comedy of the current generation, right? Comedy, it shifts from generation to generation. So if I don't try to ascertain why certain jokes aren't working anymore and update my jokes, then I'll fall behind. eventually just be a boring math teacher, which I guess would be okay, but I don't know. Let's see here. So example 15, what we got? Okay, this one's pretty easy. 100, well, not that easy. 100 to the minus 3 halves power. So if we don't, of course, if you have a calculator that has that function, go for it. But it's useful for us to think through it because it helps us improve our algebra steps. So this would be 1 over 100 to the 3 halves power, right? But I think a better way to think about that is 1 over 100 to the 1/2 power cubed. What is 100 to the half power? And that's a different way of writing the square root of 100, right? What's the square root of 100? 10. Very good. So we're actually looking at 1 over 10 cubed, also known as 1 over 1,000. All right. Let's add some letters to the mix. 5xy to the minus 5/6 power. What did I say? Minus what power? Minus 5/6 power. So we're supposed to rewrite this as an expression just using positive exponents. So we can just write that as 1 over 5xy to the what? To the 5/6 power, right? Is that an expression using only positive exponents? It is, so we're done. Because there's not much more you can do to simplify that, really. All right. Let's see here. I'll continue with the instructions that I've written. Let's see here. All right. A to the minus 3 halves over b to the minus 5/3. All raised to the what? One-third. All right. So the way I would approach this problem is to say, okay, so this is, you can either work inside the exponent, inside the big parentheses to start with, and then, use the 1/3 on that. I think that's probably the right way to go here. So we're just going to simplify what's inside the big parentheses to start with. And so the thing is, this is b to the 5/3 over a to the 5/2. So what did I do there? Do you see how I moved the thing upstairs, downstairs, but changed the sign of the exponent? And likewise, I moved the thing downstairs, upstairs, but changed the sign of the exponent. So I'm using two things, really. The one is that if you have a to the s, that's equal to 1 over a to the minus s. Like generally speaking, for positive a, I can do that. And likewise, 1 over b to the s. 1 over b to the 1 over b to the s is equal to b to the minus s. Of course, you can also put minuses, right? So a to the minus s is 1 over a to the s. 1 over b to the minus s equals b to the s. These are different algebra shortcuts that you can use. Sorry, my s's are so horrible. Okay, then what? So the other law of algebra that we can use is if we have a over b to, let's say, the t power, that's a to the t power over b to the t power. All right, this is a rule of algebra. So we should use that here to try to simplify things. So we have b to the 5/3 to the 1/3 power over a to the 5/2 to the 1/3 power. And then what other law of exponents do we get to use in this problem? Well, remember, a to the s to the t power is a to the st, right? So we multiply exponents in this case. So what's 5/3 times 1/3 is what? 5/9, right? And what's 5/2 times 1/3? How do you multiply fractions? Multiply the numerators, multiply the denominators, right? So what's that? A to the what? 5/6, very good. And there you go. You can't really simplify it more than that. All right, so let's work some problems that have a little bit more to them. What if we had, x to the minus 2, the square root of x cubed y to the minus 2 divided by the cube root of xy times y to the minus 1. There, that's pretty horrible. Let's try to simplify this. So what should we do? Well, get rid of the negatives is a good idea. So I'll do it with the part that I can. That's going to be y over x squared, right? I just took care of those two. And then I'm also going to, at the same time, I'm going to use the property we know about radicals, which is that that's the square root of x cubed, right? Times the square root of y to the minus 2. And downstairs I've got the cube root of x times the cube root of y. Now, if you don't like cube roots, you could switch it over to the 1/2 and to the 1/3 power as appropriate, It's kind of up to you, but there it is. So now what I do at some point here is just shift everything over to the exponent notation, because that's where I can use the, you notice all these nice rules of algebra, they're all in the exponent notation for the most part. So like, there are corresponding rules for radical notation, but it's just, I personally find it much easier to work in exponential notation. So one of my goals is to get rid of radicals and switch over to exponents if I'm doing a lot of simplification like I'm doing here. So anyway, we got y times x to the, hey, wait a minute, what's the cube root of, well, the square root of x cubed. It's not just x, it's x to the what? X to the 3/2. And then I've got y to the minus 2 over 2. And then x squared, x to the 1/3, y to the 1/3. What are the instructions we're working with? Rewrite everything with positive exponents, right? So which of these things is not like the other? Which of these does not belong? Which one's negative? I mean, that one, right? So we want to move that downstairs. So we've got, let's see here, we've got y, x to the 3/2 divided by x squared, x to the 1/3, y to the 1/3. That's just minus 2 over 2 is what? Minus 1, right? So that just brings it down as y. We should try to simplify this, right? So my question is, as you look at the numerator and the denominator here, which one wins? Like, if we want to keep x and y with positive exponents in our answer, should we keep x upstairs or keep it downstairs? Downstairs, I've got this x squared, right? That's going to be hard to beat. That's the largest power there, isn't it? So I think we need to bring the x's into the denominator in order to make the answer have positive exponents. So what I'm going to do, in fact, well, look at that. I always look for something like this. If this happens, great. They cancel, right? So we don't need to think about that more. So apparently both x and y are going to go in the denominator. And so what we have is 1 over, I'll write it bigger here, x to the 2 plus 1/3 minus 3/2, that's my x powers, and then y to the what? Just y to the 1/3. So what is 2 plus 1/3 minus 1/2? In terms of twelfths, that's, in terms of sixths, how about that? Let me not be an idiot. 12 plus 2 minus 9 in terms of sixths, is that right? (14) minus 9 is 5/6, so 5/6. So what I get is 1 over x to the 5/6, y to the 1/3. All right. Similar question. In fact, pretty much the same question as I just asked, except I'm going to just switch up the formatting on us a little bit. So x to the minus 2 square root of x cubed, y to the minus 2, right? Over the cube root of xy times y to the minus 1. I'm going to say that that's equal to x to the a, y to the b. Find a and b. So we've already worked out that this is equal to what? 1 over x to the 5/6, y to the 1/3. How do I rewrite that as x to the something times y to the something? Fill in the blanks for me. How do I manipulate that expression to rewrite it as x to a power times y to a power rather than division? Surely somebody here knows. All right, fine. Minus 5 over 6, right? And minus 1/3. So when I move these upstairs, I have to change the sign of the exponents. This is, oh, that was equals. Sorry, I'm trying to write an equals vertically. Maybe I should do one of these deals. I don't know. I should be more civilized. I should just, I should have done. Forget that. I should have called this Pac-Man. And then I call this Pac-Man. There we go. So what's A and B then? Well, here A and B are whatever. See, this is the pattern we're looking for, right? So what are A and B? Did you say 5 over 6 or negative? No, negative. Okay, so negative 5 over 6. I didn't hear the negative. Now, you might have said the negative, and I just didn't hear it. That is completely possible. All right, let's see here. So something that we talked about, but we haven't come back to in a little bit. Let's talk about it. Oh, I guess that's not the case here. Let's see here. Well, example 20. So if I have the fourth root of x to the fourth, right, what's that equal to? If I have the cube root of x cubed, what's that equal to? Say again? That's true. But okay, so I should. Well, so this is, you're like x to the 4 over 4, which is just x again, x to the 1, which is x, right? And x to the 3 over 3, which is equal to x to the 1, which is equal to x again. And so this is where I wanted to throw in a cautionary comment. Caution. So I don't think you guys are wrong. I think you guys are totally on the money, like, great. But this assumes something. We've assumed x is greater than 0 to make that simplification. So what I'm really trying to say is the laws of exponents, I sometimes say this, I sometimes don't, but is a presupposition for like about half of the laws we write that we're working with positive bases, like the a and the b that we're raising to a power, they're positive. If they're not, it's a little bit more subtle. It may or may not make sense what we're writing. And in fact, so if generally, the fourth root of x to the fourth is actually equal to absolute value of x. To give you an example of this, if I take minus 2 and raise it to the fourth power, and take the fourth root of that, well, that's the fourth root of 16, which, by the way, is 2. But 2 is not equal to minus 2, right? 2 is equal to the absolute value of minus 2. So I mentioned this before, I talked about it, and then we just kind of like left it behind us as we're doing these simplification problems, right? I'm just warning you that there are contexts where this matters. So that's why if I just intend for you to simplify and use laws of exponents, I try to make a comment before the problem that says, assume the quantities are positive. I want you to know that you have full license to use the laws of exponents without worrying, right? I mean, check this out. Why it's trouble. So